sitting on our 4 billion-year-old planet, basking in the 5 billion-year-old sun, standing in the 200 million-year-old Jinsha River, and handling 85.8 billion cubic meters of water, is a mega hydraulic engineering project that boasts 16 of the world's top million-kilowatt level hydropower generating sets. Developed independently by China, once completed, it will have an annual generation capacity of over 60 billion kilowatt hours, saving 28 million tons of coal, an amount equivalent to the total produced by 7 large thermal power plants. This is the Baihetan Hydropower Station, China's mega energy plant. 1,070 kilometers southeast of Baihetan, on a 51 square kilometer sea area in Wailuo Sea Area, Zhanjiang, the southernmost part of the Chinese mainland, 68 towering wind turbines are turning industriously. Their wing-like blades, with a diameter of 180 meters, capture energy from a wind that blows at an average annual speed of 7.2 meters per second and turns it into electricity. When the Wailuo wind farm is completed, it will be able to generate 1 billion kilowatt hours annually, equivalent to the annual electricity consumption of 650,000 households. However, it is a formidable task to erect the 100-meter tall tower before installing blades longer than the wingspan of the Airbus A380. This piece of mega equipment is needed for the job. It features 4 85-meter-long legs which can support over 10,000 tons. It is an offshore engineering crane with a lifting capacity of 2,000 tons and a deck that is 128 meters long and 43 meters wide, roughly half the size of a standard football field. It can effortlessly lift piles that are over 90 meters long and weigh more than 1,000 tons, and drive them vertically deep into the seabed with a margin of error of less than 3 in 1,000. The Longyuan Zhenhua 3, China's largest self-elevating wind power installation platform, currently in service. Over the sea, 150 kilometers away from the continental shelf and 340 kilometers south of the Zhanjiang, sits a giant machine island consisting of over 24,000 parts. Anchored by 16 special chains, each over 2,500 meters long. Standing at a height of 120 meters, the equivalent of a 40-story building, it weighs over 50,000 tons, with a projected area the size of 2 football fields and tonnage equivalent to that of 3 medium-sized aircraft carriers. It gathers daily 10 million cubic meters of natural gas from 1,500 meters below the surface. This is equivalent to a daily production of 70,000 barrels of oil. China's self-built Shenhai 1 is the first 100,000-ton semi-submersible oil production platform in the world. Scientists estimate that by 2025, the concentration of carbon dioxide in the Earth's atmosphere will reach its highest level in the past 15 million years. To meet the enormous energy demands of its 1.4 billion population, China is increasing its efforts to develop and utilize clean energy, with hydropower being the most effective and mature method. The Baihetan Hydropower Station, the 4th Cascade hydropower station in the lower reaches of the Jinsha River, has an installed gross capacity of 16 million kilowatt hours, the second largest in the world after the Three Gorges Dam. Early in the morning, the construction site of the dam is already busy, as 7 cable cranes move across the precipitous river valley, continuously delivering buckets of concrete to the site. The Baihetan hydropower station consists of the dam, the underground power plant and the spillway. The reservoir formed by the dam serves as an energy storage pool, accumulating the potential energy of the waters from the upper reaches of the Jinsha River. The underground power plant acts as a converter, transforming the potential energy into electrical energy. The spillway, on the other hand, works as a dissipator, dissipating the potential energy of the water by discharging floodwaters when they peak. Baihetan looks completely different from Three Gorges. The latter is a gravity dam, relying on its own weight to sit steadily on the river, whereas the former is an arch dam that utilizes the arch-shaped design to transfer the pressure of water to the mountains on both sides. The Baihetan Dam was built with concrete poured from buckets hung from cable cranes. The buckets, each weighing 30 tons, were hoisted up to designated locations by the cranes. It took 970,000 such deliveries to complete this rare arch dam. Just as the pouring of the dam reaches the critical final stage, engineer Tan Yao-sheng suddenly receives an alert message on his phone that warns of an abnormal temperature at a certain part of the dam. What is going on? So far, cement concrete remains the first choice for dam construction. However, cement tends to heat up during the setting process. The temperature can rise up to 70 to 80 degrees Celsius. The construction of the 289 meters high and 709 meters long Baihetan Dam required over 8 million cubic meters of concrete. That's more than 3 times the volume of material used in the construction of Khufu's pyramid in Egypt. The natural cooling of that volume of concrete would take about 140 years. Obviously, the dam cannot wait that long. Even worse, the concrete tends to crack in the process. The surface cools down and shrinks rapidly after being exposed to cold air, yet the inside continues to heat up and expand. Due to the thermal expansion and contraction, cracking is inevitable. How then will the Baihetan Dam overcome this universal challenge? To the naked eye, this concrete is no different than regular concrete. Its secret, however, lies within. In the cement factory, specially formulated concrete is being mixed with ice cubes and icy water, keeping it at a temperature of 6 degrees Celsius when it leaves the factory, thereby making Baihetan the world's first dam built with low-heat cement. However, during transportation, the temperature of the concrete will rise due to the temperature outside. Therefore, insulation layers are installed on the interior walls of the vehicle to ensure the temperature remains at 12 degrees Celsius upon arrival. But is this enough to reassure the engineers? Tan Yao-sheng's team, upon receiving the alert, starts an immediate search for possible reasons for the abnormal temperature rise inside the dam via a smart central control system powered by massive data. The setting of concrete is a complicated chemical and physical process. The concrete is only at 12 degrees Celsius when it is delivered, but the interior temperature will continue to rise during the setting. So, what should be done if the temperature exceeds the limit? The dam is built by pouring concrete into 3 square meter sections, one by one. 3 thermometers are placed in each section to monitor internal temperature changes, and the data is uploaded in real time to the smart central control system. It is like the nervous system of the dam is connected to its brain, the central control room.
把我们施工全过程的数据，包括开挖、混凝土浇筑、温控、灌浆、经节自然等等这些所有的信息啊，都通过现场采集的方式传输到我们系统里面，然后进行数据的分析，以这个分析的结果进行现场的控制。
During the pouring, besides the thermometers, cooling water pipes are pre-laid in each section. Water at a temperature of 12 degrees Celsius runs through the pipe continuously, carrying the heat away and keeping the internal temperature of the concrete below 27 degrees. Once the temperature exceeds this limit, the smart control system will automatically increase the water flow to cool the concrete down. In this way, the construction process avoids cracking due to the internal expansion and external contraction of the poured concrete. Offshore wind power is widely considered the most promising green energy in the world today. Since 2018, China had been the global leader in new-built installed capacity of offshore wind turbines for 3 consecutive years. According to the Global Wind Energy Council, as of 2020, China had installed a total generation capacity of about 9,900 megawatts. The country, once suffering from alarming coal pollution and highly dependent on imported oil, has demonstrated its determination to achieve carbon peak and carbon neutrality to the world.
中国海上风电近10年的大规模发展，风机不断的加大。原来最早我们3兆瓦风机，到现在都是6.45兆瓦风机，包括后面更大的7兆瓦、10兆瓦风机，包括水深10米水深，到现在20米、30米、50米水深，离岸越来越远，就更需要适合我们这个中国海域的更大的、更好的装备。
It's daybreak at the Wailuo wind farm, and the lifting and installation of tower sections has already begun. An offshore wind turbine is made up of 4 parts: the foundation piles, the tower, the blades, and the rotor. The foundation piles are like roots that are embedded firmly into the seabed. The tower is like a torso that supports the rotor. The blades are like wings that capture the wind, and the rotor is like the heart that converts wind power into electrical energy. The tower is installed by assembling 4 tower sections, and the one being lifted now is the second. For Wang Lingpeng, the on-site chief director, this is a race against the clock because strong winds will blow up in 48 hours, and he must finish the hoisting before then. As for Longyuan Zhonghua 3, which has a lifting capacity of 2,000 tons, hoisting one of the 4 sections, which weighs a mere 200 tons, is a piece of cake. Hoisting the piles, which weigh over 1,000 tons, up in the air and driving them vertically into the seabed is its forte. However, while the howling wind in Wailuo Sea area generates enormous electrical energy, it also exacerbates metal fatigue of the crane booms day by day. Lifting a 1,350-ton pile to a height of 140 meters above the sea surface is akin to raising 10 fully grown blue whales to the top of a 47-story building. The metal fatigue caused by the twist and pull of the surging waves and the erosion of the salty sea wind can damage the equipment or even overturn the platform, causing casualties. So, how is metal fatigue tackled? The secret lies in these irregular bulges at the joints between the boom and the jibs. On the girder, made by joining high-strength steel tubes seamlessly together, the traditional spot welding will render the weld between the boom and the jibs extraordinarily complex. Even the tiniest flaw in welding will lead to build-up of metal fatigue. The inclusive joints, on the other hand, are a smart solution to the problem.
这个包容式节点，它是一个鼓，上面开一个孔，这个管子插进去，不需要对这个管子的这个精度要求有多少高，然后它插进去的距离它可以调整，所以本身它就可以减少这个误差的影响。
Nonetheless, it is not easy to process those irregular bulges. Not only does it involve complicated calculation on thickness and angle of the steel plates, but once they are punched to shape, they must be drilled before the jibs are welded onto the bulges from different directions. With inclusive joints, the contact area between the boom and the jibs is enlarged, eliminating 2/3 of the fatigue stress, and thereby reinforcing the crane arm as a whole. With the ingenious inclusive joints, Longyuan Zhenhua 3 makes it look easy to hoist a pile 8 meters wide and weighing 1,350 tons. However, a new issue soon ensues. As the pile goes into the seabed, sea currents will inevitably make it tilt. Any deviation will render the 20 million yuan worth pile useless, and the redundant pile will block the sea route, posing threats to passing vessels. So, how can the pile be driven vertically into the seabed with perfect precision? The pile is held between these retractable arms. Their firm grip keeps the pile perfectly still. These strong arms are the double-layer pile gripper developed independently by China. The pile gripper, with a diameter of 10 meters, is composed of upper and lower layers of circular clamping arms, within which multiple hydraulic cylinder-controlled sensors and a high-pressure jack are installed. During pile driving, these sensors can accurately detect the degree of the tilt and transmit relevant data to a computer. The computer then adjusts the force of the jack accordingly, pushing the pile toward the center of the circle to rectify the deviation within a margin of error of less than 3 in 1,000. On the deck, the lifting and installation of the tower is nearly complete. With the foundation piles steady as a rock, the tower will stand firm against strong winds and violent tides. Petroleum, the essential energy source for modern society, is hailed as the blood of industry. China, the second largest oil consumer in the world, consumes 14 million barrels of crude oil every day, while producing only 3.8 million barrels. The enormous gap has forced China to accelerate its oil and natural gas exploitation. Offshore oil and gas exploitation, in particular, is the key in China's future energy strategy.
在世界海洋石油的发展史上，整个石油工业产量的增长点在海上，而海上的增长点在深海。随着能力和装备和技术的提升，也是生存和发展的需要。石油开发从陆上往海上发展，逐渐的又从浅海往深海去走。
However, standing between Shunhai 1 and the treasure beneath the ocean floor is a perilous depth of 1,500 meters. Add to this the complex seabed formed by 3 tectonic plates crashing into one another, and the giant waves over 23 meters high caused by typhoons moving at 300 kilometers per hour. So, how can Shunhai 1 operate all at the sea for decades in such a harsh environment? The part of Shunhai 1 above water consists of the upper module and the lower hull. The upper module is installed with nearly 200 sets of oil and gas processing equipment. making it a full-on chemical plant. The lower hull is composed of 4 20-story high-floating columns that keep the platform afloat. Soon after daybreak, the installation of the umbilical cable begins. Working alongside Shanghai 1 is HYSY-286, China's first offshore engineering ship, capable of operating to 3,000 meters deep. On the deck, buoys are being attached to the cable, which will be placed 800 meters deep in the sea. A buoy is required every 3.5 meters, so this 5,000 meter long umbilical cable, which is worth over 10 million RMB, can unfold as an S-shaped catenary underwater instead of being squeezed and tangled by its own 516-ton weight. Under the sea surface lies Shanghai 1's vast and complex subsea Christmas tree, which comprises the well, the pipeline, the manifold system, and the umbilical cable. The oil comes out of the well and is transported through the pipeline. The manifold system gathers oil and gas from various wells before delivering it to the Shanghai 1. The umbilical cable serves as both the power line and the central nervous system for the subsea tree. In addition to supplying power for underwater production, it also transmits instructions from the platform to the underwater production system.
对于深水油气田开发来说，水下生产系统是非常重要的。整个海上平台跟水下采油处最重要的部分就是水下脐带缆。海上平台的电力、液压动力和化学药剂等生产动力源源不断的通过脐带缆输送到1500米海深、30多公里远水下设备使用。
In certain conditions, natural gas and water combine to form natural gas hydrate, a crystalline substance that can clog oil pipelines. The low temperature of the sea at 1,500 meters deep is perfect for its formation. To prevent the formation, glycol is injected through the umbilical cable into subsea wells to inhibit crystallization. Within the reel cabin of HYSY-286, the massive capstan rotates slowly, transporting the umbilical cable to an upright laying rack in the middle of the deck. As the moon pool slowly opens, the tensioner, like an octopus tentacle, grasps the umbilical cable and lowers it into the sea with great precision. One end of the cable has been placed 120 meters underwater. Shanghai 1's winch is ready to pull up the cable and connect it to the platform. However, it is not an easy task for this floating work platform. 16 sturdy anchor chains are tensioned by 16 powerful windlasses. This mooring system serves to stabilize the floating offshore platform. The secret of Shanghai 1's ability to resist the wind and waves rests with the 16 special submerged anchor chains. Traditionally, a mooring system uses steel anchor chains. These are not suitable for Shanghai 1. A steel chain over 2,500 meters long weighs 20,000 tons. So 16 such chains would weigh 320,000 tons in total. Under pressure from the sea currents, the excessive weight of the anchor chains would generate enormous inertial force, unbalancing and even capsizing the platform. Shanghai 1 uses a new type of anchor chain that comprises of 3 sections. The head section, 200 meters long and connected to the platform, is made of steel because it's constantly reeled by the windlass. The tail section, 300 meters long and fixed onto the seabed, is also made of durable steel, so it can withstand the long-term friction against the seabed. The middle section, 2,000 meters long, is made of a newly developed polymer polyester material, which is as strong as steel at the same diameter, but less than 1/40th of the weight. These innovative anchor chains are what keeps the floating Shunhai 1 relatively steady and makes possible the precise docking of the umbilical cable with the platform. The winch starts to pull the umbilical cable with extreme delicacy, but it soon stops unexpectedly. The winch only needs 28 tons of its maximum pulling capacity of 45 tons to pull the cable. However, as the pull reaches 30 tons, the cable stops moving. And it remains that way even when the pull is increased to 34 tons. Tension rises in the main control room. Yo Shui-gang, the project manager of Shunhai 1, watches on anxiously, as he knows too well that the installation of the umbilical cable will not only affect the progress of the project, but also the safe offshore operation of Shunhai 1 for decades to come. What could the problem be? At the Baihetan Hydropower Station, a long tunnel meanders its way deep into the mountains on both sides of the dam. This vast underground palace is the power plant, the station's energy converter. The rotor of number 2 hydropower set is about to be installed. The rotor is the key component of the power plant, with a diameter of 8.62 meters and a height of 3.92 meters. It is composed of 15 11-ton blades weighing 353 tons in total, equal to the weight of 6 high-speed train carriages. To make a home for the 16 sets of generators, a massive complex of underground caves must be dug out of the mountain for the power plant. The underground palace extends for 217 kilometers, about the same distance of a round trip from Beijing to Tianjin. The excavated earth and stone could fill a lake twice the size of the famous West Lake in Hangzhou. The actual excavation and shoring up, however, is a huge challenge.
百会滩工程应该说是目前世界上唯一一座300米级高坝建在了柱状节理玄武岩之上。咱们这岩石啊，就像一把筷子一样，一个一个的柱子在一起。你如果在不扰动它的时候，在周围都围压比较好的情况下，它的这个性状非常好。但是你把周围的这个筷子这个笼子一旦打开，就是咱们一把筷子全部散开了。
The unique structure of the columnar jointed basalt renders the foundation of this 300-meter-tall high dam loose and fragile. With no previous successful examples anywhere in the world to draw on, how will the Chinese engineers tackle this problem?
我们能不能在开挖之前，在我们这个筷子笼子里面的时候，先用胶水把这个筷子一个一个的给它粘起来，然后我再开挖，它不就是一个整体了吗？
To turn the loose rock stratum into a stable entity, the engineers invented multiple techniques such as surrounding rock grouting and energy dispersion blasting. Through a series of measures including pre-grouting, anchoring and secondary grouting, a firm foundation is formed to guarantee the stability of the dam. Hoisting the rotor begins. The bridge crane, with a lifting capacity of 1,300 tons, steadily and carefully moves the rotor to its designated location. The rotor, however, is not the first stopping point for the waters of Jinsha River. The spiral cavity and orange paint make this conch-shaped space look like some fantasy domain. This is the spiral casing located at the bottom of the hydro generator. Water from the upper reaches of the Jinsha River will enter here first through the inlets on both sides of the dam. The vertical drop from the inlets to the casing is about 200 meters, the height of a 70-story building. Due to this huge height difference, water going into the casing carries with it tremendous power. The spiral structure of the casing further enhances that power. The water rushes over the rotor, making it spin at high speed, thereby turning the potential energy in the water into mechanical energy, which is then transformed into electrical energy. To withstand the massive impact of water falling from a height of a 70-story building, the casing is made of yield 780, a special high-strength steel with a yield strength of 780 megapascals. Material bearing 780 megapascals of gravity over each square centimeter is like having two full-grown African elements standing on a human fingernail. That gives an idea of how pressure-resistant the casing has to be. The colossal rotor is finally hoisted to the generator, first above it and then in the exact center of the casing. Soon this energy converter will bring light and heat to tens of millions of households across China. At the Baihetan offshore wind farm, the weather appears to be suddenly changing. The Longyuan Zhenhua 3 must begin the rotor installation as soon as possible. The rotor is the heart of the wind turbine. Docking the rotor to the tower section is not an easy task. The offshore operation is susceptible to wind and currents, posing tremendous challenges to the precision installation. Not to mention, the docking must be done high up in a howling gale. To deal with the volatile situation, Longyuan Zhenhua 3 must first ensure its own stability. To this end, the platform is designed to operate in a self-elevating upright fashion, with 4 legs rooted into the seabed. Each leg is 85 meters long and can withstand a weight of over 4,000 tons. The 4 legs together are enough to support the platform that weighs over 10,000 tons. After the legs are firmly rooted on the seabed, the elevating system pushes the hull up into position, rendering the floating platform stationary.
有这4条腿以后，把这个平台升起来，它就像一个海岛一样，一个岛它就稳了，体重就在固定这个岛上来坠了。
The stabilized Longyuan Zhenhua 3 hoisted the 247-ton rotor to the top of the tower section. Thanks to the skillful and meticulous adjustments made by a team of experienced workers, the docking is a complete success. Next is the installation of blades. Each blade is carefully hoisted over the deck, ready to be attached to the hub to form the 180-meter diameter turbine. After the blades are hoisted into position, 116 stud bolts are aligned with the holes on the hub before being tightened. With the rotor and the tower in place, finally the blades can be installed. Wang Lingpeng suddenly looks grave. The strong winds previously estimated to arrive in 48 hours have arrived early, and the wind speed has increased to 12 meters per second. The blades can only be installed when the wind speed is 4 meters per second or below.
叶轮因为它都是玻璃钢的材料，风大了之后拉不住，然后导致那个就是叶轮在上面两边就是摇晃，撞到吊机的臂架。
Furthermore, the blades are to be aligned with the rotor atop the 130-meter high tower, where wind is even stronger. Given the blades are designed to catch the wind, aligning them will be extremely difficult. As the anemometer spins rapidly, Wang Lingpeng checks the weather forecast with anxiety. It's predicted to be windy in the next few days. There is nothing to do but to wait it out. Fortunately, he is accustomed to the capriciousness of the sea. He is little surprised when the relentless gale of the night before suddenly dies down early in the morning. The clock is ticking. The installation starts immediately. The crane lifts the blades steadily up in the air before aligning them with the rotor for docking. The whole process goes smoothly, and another wind turbine soon adorns the oceans. A sense of foreboding permeates the main control room of HYSY 286. Since the winch is unable to pull the umbilical cable, the engineers decide to send a diver down to check if the cable is stuck before making a properly informed decision. The diver Shi Xianjun reports back that, as suspected, the drawing head of the cable has caught beneath the platform. The only option they have now is to have a diver tie a temporary cable to the head and use a crane to loosen it. There is palpable tension in the control room. No one can be certain that the plan will work. Pulling the umbilical cable in that way may cause damage to it, resulting in substantial operational and financial losses.
主脐带缆就相当于我们的中枢神经，一次性必须做对、做好。无论是密封出现问题和打压施不住的时候，如果不能修复的话，我把它解下来，然后我再把它回接上，我大概就要花5、6个亿。
Meanwhile, down in the lower hull of Shunhai 1, inspection of the oil storage tank security alarm system is taking place. The 60-meter deep tubular well resembles an upside-down building with its zigzag stairway leading straight to the center of the Earth. It is as if one could walk into Jules Verne's fictional world by following the stairs downward. Shunhai 1's gigantic oil tanks are inside these 4 square columns that have a total volume of 20,000 cubic meters. They are capable of storing approximately 120,000 barrels of oil, twice the capacity of the Olympic Swimming Centre's pools. The crude oil and natural gas extracted from the deep undergo a three-phase separation process at the chemical plant. The natural gas is compressed and then transported via subsea gas pipelines to dry land 150 kilometers away, while the oil is stored in the tanks, waiting to be loaded onto tankers. Given the immense volume of oil on board, Shunhai 1 could be seen as a gigantic floating bomb. In the event of a leak or fire in one of the tanks, the consequences could be catastrophic, posing a massive environmental threat to the entire region.
安全是一个很系统的一个复杂的工程，通过这个结构强度、疲劳计算，整个平台的这个设计寿命是30年，但是很多这个关键点的这个疲劳寿命要求达到150年，特别关键的地方要达到300年的疲劳寿命。100年一遇的台风，浪高最大是23米。100年台风袭击我们的时候，我们这个设施还有1.67倍的安全系数。1000年一遇的时候，我们这个地方的浪高会达到29米，29米袭击我们的时候，我们还有1.0倍的安全系数。
The intense inspection continues. They must ensure that the monitoring, pressure relief and fire extinguishing systems are all in perfect condition. The tank has a double shell design, which means there is an isolation zone outside the tank, equipped with an oil leak detector, pump and ventilation system. If an oil leak is detected, the pump and ventilation system will activate automatically as preventative measures. As night envelops the sea, the good news finally arrives. Pulling from the crane has worked. The jammed head is freed, and the winch begins to rotate slowly, with the pulling tension gradually returning to normal. As the head is pulled up little by little, the umbilical cable is successfully docked to Shunhai 1. The sea breeze in March has driven away the gloominess of the past 2 days. HYSY 286 has now reached its destination above the subsea wellhead and is lowering the other end of the umbilical cable into the water. The ROV underwater robot is capable of operating at depths of 3,000 meters. It is about to show off its skills. 2 ROVs are released into the deep, 1,500 meters below. The engineers control the robots with joysticks, as if playing a video game. As the robots carry out their underwater tasks, the other end of the umbilical cable docks smoothly with the seabed wellhead. Despite their numerous difficulties, the engineers believe every cloud has a silver lining. From the initial plan in the 1950s to the operation of the first batch of generators on June 28, 2021, the Baihetan station embodies the dreams and dedication of generations of Chinese hydropower workers. Across the Wailuo Sea area, endless rows of wind turbines are capturing energy from the wind. From China's first offshore wind farm near the Donghai Bridge in Shanghai, to the Wailuo wind farm in Jianjiang, on the southernmost part of the Chinese mainland, thousands of miles of China's coastline is dotted with innumerable pieces of mega equipment. On June 25, 2021, the flare boom of Shunhai 1 was ignited, marking the beginning of a 30-year service period for the world's first 100,000-ton level semi-submersible energy production platform. Its undersea pipelines will deliver 3 billion cubic meters of high-quality natural gas per year to China's Hainan province and the Guangdong, Hong Kong, Macau Greater Bay Area, fulfilling a quarter of all residential gas needs. A philosopher once said that time is like a river that bears up things light and swollen and drowns the weighty and solid. These ordinary builders at Baihetan, Longyuan, Zhenhua 3 and Shanghai 1 have devoted their life to the construction of mega equipment.
以前有一句话啥？远看像套荒，近看像要饭，仔细一看，搞水电。因为每天一身泥一身水。
我们有6个月都没上去，因为海工啊这个东西，窗口期是有限，那必须在窗口期把这个工作做掉。
搞这个灌浆工程，长期不见太阳，人家说你白就是因为那啥的，就是因为闷的。3班倒2班倒，怎么倒呢？你上白班。白天在洞子，晚上睡觉，对吧？一天24小时你都可能见不到太阳，所以说我们自称叫地下工作者。
说不想想也是假的，肯定想哈。
如果有的选择，我会选择离家近一点的地方，好好照顾一下老母亲。
如果说我欠家人的，我欠老妈的一个忌日。我不是大小，
这2、3年基本上没有回过家。回去也就是匆匆2、3天，又要出发。
我爱人打电话跟我说：“你1年没有休假，老爷子90多岁了，还有几年不知道。我不想让你油气缸有任何的遗憾。”
希望我的老婆、我的儿子、我的女儿可以健健康康、快快乐乐的生活。
后悔不后悔？我自己也想过，每天早上可以看对面山上的云。我们去的都是处女地，都是别人的风景区没开发的地方，我们去的。假设要重新来一回的话，就像人的一生重新来嘛，有可能你还会走这条路。
我主要就喜欢蓝色，喜欢海洋的一种情怀吧。这片风机全是经过我的手钓上去的，有时候晚上看看，也是觉得挺有成就感的。它也使一个人的性格得到了一个改变，一个升华吧。因为大海就包容了一切，喜怒哀乐全部在里边了。